Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Colorful Arrows by Surmoose, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have numbers along an arrow summed to the number in that arrow's bulb. 2-digit bulbs are read from left to right. So these digits here must add up to a 2-digit number here. And it reads, this is the tens digit and this is the ones digit here. Let's give an example. Say this is 4 and 5, then this would have to be 9 here, because the 2 digits along the arrow must equal what's in the bulb, which is a 9. So 4 and 5 add up to 9, so therefore this must be 9. And that's an example of how arrows work. Each arrow also has a separate rule, and these rules do not affect the digit in the bulb of the arrow. So they are only related to the arrows that are on this, the digits that are on this arrow. They do not apply to the bulb. Digits along the red-orange lines must alternate parity. Therefore, they must be odd or even. So therefore, this works here because this is even and this is odd. And this doesn't have anything. The bulb is not related to that, remember. So for digits along a red-orange line, they must alternate parity. That is, they must be odd and even, swapping. For digits along a purple red band line, they must be consecutive digits in any order. So this actually works for both this too, right? So if you had 4 and 5 here, that also works because then they would be consecutive digits. And digits along a blue lines must sum to the same number in each 3x3 region the line enters. So for example, these 2 digits must equal what this digit is because they sum to the same sum as this digit, right? Because they must sum to the same number in each 3x3 region. So this is a separate 3x3 regions as that. So these must sum to the same sum as that. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. This is essential. So, for these blue lines are known as also region sum lines. So, region sum lines, again, this must be the sum of 3 unique values because this is equal to the sum of this, which is equal to the sum of that. It's a singleton digit here, so therefore it's 6, 7, 8, or 9 because it's the sum of 3 other unique digits here. So this has to be 6, 7, 8, 9, right? Because you could have 1, 2, and 3 at minimum, or going up to 9 as the largest digit. So if this is 6, this would have to be 18, because it's 3 times that, right? Because these all must sum to the same sum. So then you would have, if that's 6, this is 1, 8. If this is 7, you'd have 21. If you have 8, this is 24. But, okay, so let's also work how that works. If this is 6, this would have to be a 1 and an 8. But to add up to 6, you would have to have 1, 2, 3 here. So this cannot be 6. If it's 7, this would be 21 here because it's 3 times 7 as a sum. But the problem with that is you can't have 1 and 2 here, but you need 1 and 2 and 4 to add up to 7 for 3 unique digits. So that doesn't work either. If you have 8 here, then this must add up to 24 because 8 times 3 is 24. But then this cannot have 2 or 4. And to add up to 8 with 3 unique digits, it's either 1, 2, 5 or 1, 3, 4. which means that neither of those can be the case, which means this can't be 8 either. So this has to be a 9, and this must be 27. So the 3 unique digits here then cannot contain a 2 to add up to 9. It cannot be 1, 2, 6, cannot be 2, 3, 4. It must be 1, 3, and 5, which leaves the remaining digits in row 7 as 4, 6, and 8. To add up to 9 here, then, it has to be 4 and 5, 6 and 3, or 8 and 1. And those are the possibilities. So we have that set there. This similarly has to basically add, these 2 digits must add up to this. You can't have a 2 in the column, so it's at minimum 1 and 3 for 2 unique digits to add up to the same digits. Well, if you have 1 and 3 and 4 there, this becomes 8, but any other combination of digits, 1 and 4 there, means this would have to be 5, but that adds up to 10, which is not a digit. So this has to be 1, 3, and 4 here, which makes this 8. This is similar here, right? So what digits can this be? So these two add up to the same number, so this must be an even number, and this is the sum of 3 unique digits. Well, this has to be 6 or 8, but if it were 8, this would have to be 4, and we already have a 4 in the row. So therefore, this must be 6, which makes this 3 here, and this is 1 and 2 as a pair. These are differing parities, so therefore 1 is going to be odd, 1 is even, which adds up to an odd sum. So this must be odd, cannot be 1 or 3, so it's 5, 7, or 9. If it were 5, the problem is it would require a 1 or 3 here, which it's not going to have. So this cannot be 5. This is 7 or 9. Cannot be 7, so this must be 9 because of 7 in the column. So this is 9, which is the sum of either, cannot be 1, 8, it could be 2, 7, or 4, 5, because we can't have 1 or 3 available because of the 1, 3 pair in the box. So this is 9. 3 eliminates 3 here. This is odd and even parity, so this has to be odd or even. So 3, 5, 7, 9. Sorry, it has to be an odd sum because you have an odd and even part. Same here. This is 5, 7, or 9. Same here. It's 5, 7, or 9. And same here. This can't be 1, 3, or 5. It has to be 7 or 9 here. Okay. Remaining digits in row 4 are 5, 7, 8, and 9. This can't be 9, obviously, here. So 5, 7, 8, or 9 there. This adds up to at most 7, so we have 1 through 6 there. To add up to, so you cannot have 5 here, because if this were 5, must be the sum of 7, which is not obviously too great. So this has to be 7 or 9. To add up to 7, you have to have 5 and 2. To add to 9, it could be 4 and 5, 2 and 7, or 1 and 8. So this is 1, 2, or 4 here. This is a renban, and it cannot have 3 on it. So to add up to this digit, well, 8 can never be here. 8 can't be here because of 8 in the row. So where is 8 in this upper central box? Can't be here because of this can't be 9. So then 8 has to be here. This must be a renban. It cannot contain 3, so it would be 1, 2 here, but that would add up to 3, so that's not possible. Obviously can't be 2, 3, can't be 3, 4. It has to be 4 and 5 here. So this is 4, 5 as a pair, which eliminates 4 and 5 in the rest of the column. This can't be 5, it's 1. This 4, 5 adds up to 9, so therefore this can't be 9, it's 7. This eliminates 1 in the rest of the box. This 4, 5 pair eliminates 4 and 5 in the rest of the box. So this can't be 4, this can't be 4, this can't be 4 or 5. This is the sum of two consecutive digits, so this must be odd also. Cannot be 4 or 5, cannot be 9, so it has to be in odd digits. 3 or 7 cannot be 1. 1 is not the sum of two unique digits in normal Sudoku. So we have a 3-7 pair in this upper central box, which eliminates 3 and 7 in the rest of the box. This can't be 3. This becomes a 1, 2, 6 triplet. If this were 7, it would have to be the sum of 3 and 4. But this can't be 3 or 4, so this cannot be 7. It must be 3 here, which makes this 7. So this must be the sum of 1 and 2, which eliminates 1 and 2 in the rest of the row, so this cannot be 2, 7. It's 4, 5 as a pair. Which means where is the 6 in this upper central box? It has to be here, so this is 6, which makes this 1, which makes this 2, which makes that 1, which makes that 2. So this is either 2 and 5 adding up to 7, or 2 and 7 adding up to 9. So this cannot be 8. Where is the 8 in row 4? It has to be here. It's the last remaining digit. This can't be 8. This can't be 1 and 8 adding up to 9. So we have a 4, 6 pair now in row 7, which eliminates 4 and 6 in the rest of the row. So this can't be 4 or 6. It's 8. Where is the 8 in column 7? Can't be here because of 8s in the boxes, and these are filled, so this must be 8 here. Remaining digits, so this is 7. It cannot be 2 here. It has to be either 1, 6, or 3, 4. This is a sum of a renban and cannot have 1 or 2. And this can't be 7. So that would mean this has to be 9, adding up to 4 and 5. Because it doesn't have 1 or 2 available. So the lowest next one is 3 and 4, but that adds up to 7, which we already have in the column. This 3 eliminates 3 here, so this is 5, which makes that 3. This is 4 and 5, so if this were 4 and 5, that would eliminate all possibilities for that cell, so this can't be 4 and 5. It's 6 and 3, which forces this to be 4. Remaining digits in, let's do column 4. We have 2, 6, and 8. And 6 cannot be either of these, so this must be 6 here, which forces this to be a 2, 8 pair. 8 cannot be added to 2 other unique digits in normal Sudoku to add up to a digit, so this cannot be 8. This is 2, that's 8. So this is even, which means both of these are odd to fulfill the parity line. So therefore, since these are both odd and this is even, that adds up to an even number. So this has to be 6 or 8. This is odd. It cannot be 3, 7, 5, or 9. So this has to be 1. So we have 1, 2, and 3 maybe, or 1, 2, and 5, adding up to 6 or 8 here. Remaining digits in column 5 are 2 and 4. Okay. Remaining digits in the central box are 4, 5, and 7. And that satisfies that. In column 6, then, the remaining digits are 8 and 9. Okay. This cannot contain 1 or 2. So then it cannot be 1, 4 adding up to 5 or 2, 3 adding up to 5. So this can't be 5. Therefore, we have a 7, 9 pair in row 4, which eliminates 7 and 9 in the rest of the row. This can't be 7. It's 5. 2 and 5 add up to 7. That makes this 9. Okay. Remaining digits in column 7 are 4, 5, and 9 cannot be here because of 9 in the box. So this is 4, 5, and this must be 9 here. Since this is 9, this eliminates 9 here, so that's 8 and 9. 5 eliminates 5 here, so it's 4 and 5. 5 eliminates 5 here, so it's 4. This can't be 4 or 5, it's 7. Okay. So to add up to 9 here, you don't have 1 or 2 available, so therefore it's 3, 6, or 4, 5. This can't be 6 because of 6 in the row, so this can't be 3. This can't be 4 because of 4 in the column, so therefore this can't be 5. This 1 eliminates 1 here, so this is 3, this is 1. Remaining digits in this upper left-hand box are 2, 6, and 7. And 6 and 7 cannot be here because of 6, 7 in the row. So this is 2, which forces this to be a 6, 7 pair. And this 7 eliminates 7 here, so this is 6, which makes this 7. 6 eliminates 6 here, so it's 8, so this must be 1, 2, and 5, adding up to 8. 5 eliminates 5 in the rest of the column, so this is 4, that's 5. 2 eliminates 2 in the rest of the column. So that's 1 and 2. This cannot be 1 and 4, so therefore this can't be 3 and 6 correspondingly. The 6 eliminates 6 here, so therefore this must be 4, which adds up with 5 to add up to 9. 5 eliminates 5 here, so it's 4 and 5, and the rest we could probably do from normal Sudoku. Remaining digit in row 2 is a 3. Remaining digit in row 3 is a 9. We have 6 and 7 remaining in row 1, so that's not too helpful. We have 8 8s. We know where the last 8 has to be. It has to be here. 9s. We have 8 9s. We know where the last 9 has to be. It has to be there. 7s. We know where 7 has to be in row 6. It cannot be here because of 7's in the boxes. Can't be here because of 7's in the column, so 7 has to be here. 6's. We know where 6 is in column, well, in this left central box because it cannot be here because of a 6 in the column, and these are filled out. So this must be 6 here, which means this can't be 6. This is 3 and 4, adding up to 7. 4 eliminates 4 here, so that's 2 and 4. And now the rest is basically just all Sudoku. So we have 6's. It could be any of those 6's, so that's fine. Where is the 6 in column 1? These are filled out. Can't be here because of 6 in the row, so this is 6 there. 5. Where is the 5 in column 1? It must be here because that's the last remaining cell. And we have 8 5, so we know where the last 5 has to be. It has to be there. 4s. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, so that's done. 3s. In column 2, 3 cannot be here because of 3 in the box, and the rest are filled, so this must be 3. That gives us 8 3s. We know where the last 3 has to be. It has to be there. 2. We are actually pretty... We don't have that much information about 2s. 1 in column 2 must be there. 1 in column row 9 has to be here. And we have now 8 1s. So we know where the last one has to be. It has to be there, which gives us 2 again. 2 has to be in row 6, has to be here, which gives us a 2 there. Remaining digit here is 7, which makes this 6, which makes that 7, and this 6. And that's how you solve it. Pretty interesting concept of having lines along the arrows. I guess it was, yeah, it was fairly straightforward to solve this. I don't know. I guess I don't know. If you don't see that break-in, I guess that could be the hard part. I don't know. My eyes was immediately drawn to that because it's the only 2-digit number. And then it was pretty restrictive about the region sum part of it. So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.